Hi guys, today we're going to talk about systems of equations. So I want to give you a little introduction to that before we try our activities because we have some fun ones to do. Before we even really get into the what they are, let's talk about why, because we want to know why we're learning this, why we care. So one time is when will you make a profit? So if you want to sell anything, any sort of business, could be a variety of things, you're typically going to have some costs associated with that. You can't just have a product without buying some stuff and like putting some of your own money into this to make it. So let's say for the purpose of this that what we're going to make is t-shirts. So people can design these custom t-shirts and then you can either use vinyl or ink or whatever to iron it on your t-shirt, have this custom t-shirt. So this is actually something that I own, which is why I'm talking about this. Let's say you want to make these t-shirts. You're also going to need to be able to get these designs. So one thing people buy are these cutting machines. You don't have to buy this one, but there's lots of cutting machines that are really great. You can design everything exactly how you like it, and then it cuts it out precisely. You can make your t-shirt. So to design these t-shirts, it's going to cost a little bit to get these machines as well as getting the materials for the t-shirt. You're going to have to get a t-shirt and get some ink or some vinyl to do that. So we want to know how we're going to make a profit. So first, let's say the machines cost about $200. So that cost is just always $200. I had to pay that much to start. And then let's say that for each t-shirt, I can get the t-shirts pretty cheap, and I can get the vinyl pretty cheap, but it's about $450 for that stuff for each t-shirt. So my cost is going to be $200 for the machines, plus $450, and I have an X there showing that it's for every single t-shirt I make. It'll go up each time. If I make one t-shirt, it's $450. If I make two, it's $9. The revenue is how much you make. It's the money that actually comes in. And let's say I'm selling them for $15 each, so that's $15 per t-shirt. So you can see just on the t-shirt part, I'm selling it for more than it costs. But because I initially put $200 in, it's going to take some time before I make up those $200 until I can get what's making a profit. Before that, I'm always below. I still haven't made back my $200 yet. So this is one example of systems of equations, why you might use it. Anytime you're trying to figure out where you're going to break even, when you're going to make that profit, or anything in business where you have multiple constraints or multiple things you need to worry about, we can use systems. We also can use it to compare two things that are not one production line, but maybe two different types of plans, like cell phone plans, or two different job offers, or things like that. Because lots of times with job offers, we're going to do a simple one, but there might be something more than just the basic salary. There's also bonuses or equity, things that you might want to get, so you want to compare how those work. So we're going to start with just basic. Let's say it's your first job, you guys are in high school, you're going to deliver some pizza. So the pizza places have different hourly pays, what they'll pay you for your shift. So let's say you always work, a 3-4 hour shift. And so one pizza place wants going to pay you $20 for your shift, but they also tip you per every pizza you deliver. So they'll tip you $3 per pizza. Pizza place 2 pays you more for your shift. They pay you $25 for your shift, but they don't tip you as much per pizza. They only tip you $150 for each pizza. So again, we have that fixed 20 and 25. That's always what you're getting paid. Then we have our 3 per pizza, so 3x and 150x. So what this can do is we can figure out how many pizzas we have to sell at pizza place 1 to make it a better deal. Because you make more per pizza, if you sell a few pizzas, you're going to make more money than you would at pizza place 2. And we can use the system to figure out exactly how many pizzas that is, so you can decide, do I want to sell 5 pizzas? Do I think I will sell 5 pizzas? Is it better to just get the guaranteed money? You can make that decision once you know how those two compare. Same with things like cell phone plans, maybe something versus unlimited data that's a little more expensive versus limited data that's cheaper, but are you going to always be going over that and having to pay more? So you can kind of make those comparisons. As always, we talk about there's always some applications to our physical sciences, our chemistry, physics, astronomy, geology. So I majored in chemistry, I talk about that a lot, so I love when we can relate them to that. So mixture problems are one that I always think of because we made solutions, we make dilutions, we add things, and we can figure that with systems of equations, how much to add, how much we have, or mixtures of isotopes, those of you who are in chemistry and know these words. We also do mixture problems that are not as chemistry related, things like when you are selling tickets at a movie theater, you have 2 different prices. You have adults and kids. So you have a mixture of those 2 people in your theater. And if we know how many tickets are sold and we know how much money you got, we can figure out how many people in the theater were adults and how many were kids by using systems of equations. We can also do a lot of things with more physics-based problems like distance and time and speed. If we know the distance at a certain time and a few different times, we can figure out the speed and how fast it's moving or changing. And we can relate things to a lot of different mixtures in geology as well, our different mineral mixtures and our gas components, and lots of things to do with all of our physical sciences. We use systems a lot in those ways. So now that we know why a little bit, let's talk about what quickly. We're going to get more into this in our activities. So it's anytime we have two or more equations with the same variables. What I mean by the same variables is that x and y need to represent the same quantities. So in my first example with the t-shirts, x was always the number of t-shirts, and y, which I called cost and revenue, is the money. So they meant the same thing. If x was t-shirts in one equation and then x is number of people you talk to in a second equation, we can't use them because they don't mean the same thing. Our variables have to mean the same thing for it to work, because our variables need to have a meaning and actually work. So of the examples up there, you can see one has 3 equations, and we get a third variable. When you have those 3 equations, we have a z. The other two only have 2 equations. Our one in the bottom right corner has an x squared, so it's a quadratic equation. The other ones are linear. Well, the top one is in standard form, x plus y. The other ones are in slope-intercept. So we can write it all types of ways, but those are all different examples of systems. Because systems is so broad, we're going to focus just specifically on systems that have 2 equations with just 2 variables. So we're not going to worry about those 3 equations or anything like that. Just 2 equations and 2 variables. And we will get into quadratic and circles because we've learned about those this year, but we're going to start just with linear today. So just x and y, no exponents, no square roots, nothing like that. So just x plus y, or x minus y, in our equations today. So the last thing, which is what you're going to do in your activities, is how you're going to actually solve this. How do we know the profit? How do we figure these out? So there's 2 ways that we can kind of split them up graphically. We can solve it by using a graph, or we can solve it by using algebra. Algebra kind of has these subheadings of elimination, substitution, and we are going to get to that in the next lessons. Today we're going to talk about graphically solving them. So that is our goal today. Because we're solving them graphically, we might have some background, but a lot of these are not going to have those applications we just talked about. They're going to be just the equations, and that's okay. We'll get to the applications and really getting there. So when we solve it graphically, we're going to do something like this. Since we're doing linear, they're both going to be straight lines, and we'll get some equations up there. We'll have our 2 equations. And we can see that they cross each other, and that is the solution. A solution to a linear equation is always an x and a y that makes the equation true. So that I get 4 equals 4 or 7 equals 7, something that's a true statement. So a solution to a system is one place where it's true in both equations, since we're only doing 2 equations at a time. So it's a point that will be true in both equations. Or, in one thing about an application, so if our t-shirt one, it's saying something like, when I sell 10 t-shirts, my cost is equal to my revenue. So I've gotten to a certain place where I've paid off that $200. I've gotten that equal spot. And that's what a system does in that case. But it's a place where it's true in both of the 2 equations. So after you've watched this little intro video, so you kind of know why we're going to use them, I'm going to have you explore when you think they are, what the answers are, what the solutions are in a Desmos activity. And that's just really going to be an exploration. So go through that. It should be hopefully self-explanatory. And then come back.